Okay, so we've been working towards figuring out how to find all of the zeros of a polynomial, and we've gotten some good clues so far. Like we figured out how we can find how many positives and how many negatives. That kind of narrows down. It would take forever to go through and check like every positive number, every negative number. So we've got one more theorem that we're going to add in that narrows down the possibilities even further. All right, so this is the rational zero theorem. So we start out with p of x is a polynomial function with integral coefficients, meaning integers only, no fractions or decimals. Then every rational zero is, and then we can come up with this nice little formula. So it's of the form p over q. Okay, so of the form p over q, where p is a factor of the constant term, and q is a factor of the leading coefficient. Okay, so the leading coefficient is always the first term. Like here it would be 1, and then the constant is just the number that's on the end without a variable. So here that'd be negative 68. Okay, so a corollary to the theorem, if p is a polynomial and the leading coefficient is 1, they're still all of the form p over q, then all of them would just be factors of p. Okay, so any rational zeros must be factors of the constant term. Okay, so it still applies to this. They'd still be of the form p over q. P are still the factors of the constant, but then if q is 1, they're all just of the form p over 1. So they would all be factors of p. So this is going to seem like it means nothing to you until I actually go through some examples. So let me show you this example right here. So we're going to list all of the possible rational zeros, and then in our next video, we're going to kind of combine everything up all together. So list all of the possible rational zeros. So the constant term is 4. All right, so the constant term is 4. So we're going to list all of those factors. Okay, so all the factors of 4. We've got plus or minus 1. 1 is a factor of 4. Plus or minus 2 and plus or minus 4. You are always going to have the plus or minus, and then the factors of 4 are just 1, 2, and 4. 1 times 4 gives us 4, and 2 times 2 gives us 4. So those are all the possible factors. The leading coefficients. Leading coefficient is 3. The only factors of 3 are 1 in itself because it's prime. So plus or minus 1, plus or minus 3. So all of the possible p over q's. So these are all the possible p's. These are all the possible q's. So we're going to just list every combination of those ratios. So all of the p over q's. So let's first take all of them and put them over 1. So we could have 1 over 1. So that's just plus or minus 1. We could have 2 over 1. So that's plus or minus 2. 4 over 1. Then we could have plus or minus 1 over 3. 2 over 3. And then plus or minus 4 over 3. Okay, so these are all the possibilities. So we went from having literally an infinite number of possibilities and only like taking guesses at it, and now we're down to 12 possibilities. 1 or 2, 4, 6, 8, 10, 12. And if you do the Descartes rule of signs, you'll be able to narrow it down like, oh, should I just be looking for positives? Should I just be looking for negatives? So when we combine these two rules up, it's going to be a lot faster to find the zeros. Okay, next one here. Your constant term is negative 15. Okay, so 15, you can do 1 times 15 or 3 times 5. So that's all the different ways to get 15. So those are all the factors of 15. And then my leading coefficient is just 1. So these are actually just all my possibilities. That matches up with the corollary that I had down here. If my leading coefficient is 1, then p over q would just be p over 1. So it's actually just these guys. And that's a special case, and that's just because my leading coefficient is 1. So I don't have to go through the process of putting this over 1, this over 1, this over 1, this over 1. Okay, so those are how we do the possibilities. In the next video, we're actually going to come up with all the zeros. Okay, we are actually going to skip right past example 2. It is a story problem, so it gets a little bit complex, and the numbers get really big and crazy, bigger and crazier than anything will on your homework or your mastery checks. So just example 3, I think, will be enough of an example to look at. So what we're going to do is find all the zeros. So we're going to combine the different tricks that we have worked with so far. Okay, so first trick that we've worked with is Descartes' rule of signs. So if we look, we've got 1, 2, 3, 4 sign changes. Okay, so in terms of positive real zeros, it could be 4 or 2 or 0. Okay, so there might not even be any positive numbers, so that's not really a good place to go off of. So let's try k of negative x and see if we can get something better out of that. So remember, when I plug in a negative number, the even powers do not change. So 2x to the 4th is still 2x to the 4th, but the odd powers switch. So plus 5x cubed, because that changes sign. The even does not change. If I plug in a negative, x squared is still x squared. If I plug in a negative x here, it will change to plus 45, and then my constant, of course, will not change. Okay, so there are no sign changes there. No sign changes at all, so I know that I have no negative answers. Okay, so that actually does give me something good to go off of. I know I have no negative answers at all, so that means that any of my rational numbers are definitely going to be positive. So that is a good place to start. So I'm only going to focus on the positive answers and not the negative answers. Okay, so now let's do our P over Q thing. Okay, so all the possibilities for Q. Q would be all of the factors of this leading coefficient right here. Okay, so my Q's are either plus or minus 1 or plus or minus 2. Those are the only factors of that leading term. Okay, so let's look at P. P would be all the factors of my constant term right there, so that's 18. So 18 could be plus or minus 1. The next would be 2. 3 is a factor of 18. 4 is not. 5 is not. 6 is. No 7, no 8. 9. 10, 11, 12, 13. Okay, so nothing else, just the 18. And you can see, like, I've got 3 times 6 is 18, 2 times 9 is 18, 1 times 18 is 18. And those are the only possibilities. So let's combine our P over Q and see all the options that we've got here. So we can do all of these first because we can put them all over 1. Okay, and then I can put them all over 2. So 1 over 2. 2 over 2 I already have, it's 1. 3 over 2. 6 over 2 I already have, it's 3. I need 9 over 2. Okay, and then 18 over 2 is 9, which I already have. So these are all of my options. It seems like a lot of options, but remember what I wrote down here, there are no negative answers. So it's actually only going to be the positives. All right, so I just cut my options in half. So no negative possibilities, no plus or minus. So I just have 1, 2, 3, 4, 5, 6, 7, 8, 9 options. So really the best way to go is to just kind of start running down the line, testing them out using that synthetic substitution. All right, so I'm just going to run down the line. I'm going to start with the 1. So remember, you put the 1 in the little box, and then we line up all, line up all the coefficients. So 2, negative 5, 20, negative 45, and 18. And we're just going to run through this process until we can find one of our zeros. All right, so move this down, I get 2. And then remember, we multiply these, giving us 2. Add these, we get negative 3, and we just repeat that process. So 1 times negative 3 is negative 3. This gives me 17. 1 times 17 is 17. Negative 45 and 17 gives me 28. I'm sorry, negative 28. And then multiply here, I get negative 28. So this is a negative 10, so this is not one of my zeros. So the 1 did not work out. All right, so 1's out. Let's test 2. So you can see this process can get a little bit obnoxious, but at least we narrowed ourselves down to some possibilities instead of testing like every positive number ever. All right, so we've got 2. We're going to do the same thing, line up these coefficients. Okay, so first comes the 2. 2 times 2 is 4, gives me -1. 2 times -1 is -2. This gives me 18. 2 times 18 is 36. This leaves me with -9. 2 times -9 is -18, and there we go. Okay, that's a good thing. That means no remainder, so we found one. Okay, so one of our positive numbers, one of our positive answers is 2. Okay, so what I can do from this point is I can rewrite it and see if I can factor. If things go well, we should only have to do this once, and then we can factor from that point on. Okay, so this was a quartic function, so I can write it as a cubic. So 2x cubed minus x squared plus 18x minus 9 equals 0. And I actually can solve this by factoring. I can group it. So group these together, and I'm running a little tight on space. I'm going to do the best I can. So here my GCF is an x squared, so I can factor that out, and it leaves me with 2x minus 1. Okay, then here my GCF is a 9, so I can factor that out, and it leaves me with a 2x minus 1. So this is a good thing. Remember, I'm supposed to have the same term in parentheses. So I am actually going to move over here. Don't mind me skipping around. So I have a 2x minus 1. That's one of my terms. Because remember, I treat this is one term and this is one term, and my GCF is the 2x minus 1. And that leaves me with an x squared plus 9. So I'm working on solving by factoring right now. So I can take the 2x minus 1 and set that equal to 0. So I add 1 to both sides, and then I can divide both sides by 2. So I end up with x equals 1/2. So that is one of my answers. Don't forget from over here, I also had x equals 2. 2 turned out to be one of my answers. So it turns out that I have 2 positive solutions. Okay, so I've got 2 so far. I might have 4. We'll find out. Now I'm going to take this and set it equal to 0. Okay, so the way I solve this, since it doesn't factor, is I subtract 9 from both sides. So I get x squared equals -9. Square root both sides, and since that's a negative number, I know I'm going to have imaginaries. So x equals, don't forget your plus or minus. You should always have a plus or minus when you're square rooting. The square root of 9 is 3, so the square root of -9 is 3i. Okay, so as it turns out, I only had 2 positives. I have 2 imaginaries. So remember, I have a total of 1, 2, 3, 4 answers, which matches with my degree of 4 from the beginning. Okay, so let me put these all in one place. So I have x equals 2, x equals 1/2, x equals positive 3i, and x equals negative 3i. And those are all of the possibilities.